So in continuation of what we were talking about in class, what happens when we're in a lab situation where we need to actually change the reference when we're assigning values? So normally in your data booklet, all the values that you see are with hydrogen being 0. Now let's say that that 0 moves, well, so will the values of all of those reduction potentials in our data booklet. So let's say I have here, and again, I'm kind of calling us to remember that when we change the cell reference for our reduction potential calculations, we're assigning another half reaction other than hydrogen is with the value of 0. So let's say, what's the value of chlorine gas if tin is assigned a value of 0.0? Now, when we go over here, and let me just go on to the data booklet here, we see that chlorine naturally has a value of about 1.36. Now that 1.36 is when hydrogen is the reference. So if I go Cl2 gas and I see that it has a plus 1.36, that's because when we compare that value to hydrogen and give hydrogen the value of 0, the difference between them is, well, plus 1.36 volts. Now, what happens if I change that 0 and I change, therefore, this distance over here? Well, that's going to alter our 1.36 value. So let's say I go as the question suggests, and tin becomes the new potential. So let's go and look at tin, and it's tin solid. Here you go. So we found tin solid, and we can see that it has a reduction potential of 0.14. Okay, so now we go back, and we would write tin below, so that'd be SN solid, and that'd be negative 0.14, sorry. So now imagine that instead of this being a 0, this is now going to be 0, and we're going to get the new value of chlorine with this new distance, if that's the 0. So visually, we can see that what we're assessing for is this greater distance. Now, the thing that I find helps a lot is to plug this all into a formula, which would be the new value equals the old value, so the one where hydrogen was the 0, so in this case 1.36, minus the new reference. And so the old value was plus 1.36 volts. The new reference is tin, and we saw that in the data booklet, tin has a value of negative 0.14. And so when you plug this in the calculator, and these become positives, we see that the value of chlorine as a reduction potential becomes 1, and it should be positive 1.50 volts. Let's try another example.